Okay, so is k-means all there is to clustering? Unfortunately, potentially, for somebody who's been asked to do lots of clustering in their life, the answer is no. There are a lot of different ways of performing clustering, um, and we're going to talk about another one. Now, it's one that I have a few personal problems with. I don't think it should be anybody's go-to, but it's been around for a long time. You see it in publications all of the time. And so I want to teach you about it because you're almost certainly, and you probably already have seen one of these, right? And this is called hierarchical agglomerative clustering, okay? And hierarchical agglomerative clustering is a mouthful. I'm just going to stick with hierarchical clustering, and I'm probably going to butcher the pronunciation of that a few times as well. So just, go with me. Now, how does hierarchical clustering work? Pretty different. Pretty different. Let's start. I mean, it's not a million miles away. All right, so let's say we've got our XY graph here, right? And we've got nice red axes, okay? And let's say we've got some data points. All right, so we're gonna just put them. Oh, let's put 1, 2, 3, 4, 5, 6. All right, how does hierarchical clustering work? All right, so first step is the hierarchical clustering algorithm requires you to calculate the distance of every data point from every other data point. And we've talked about distances before in this when we were talking about k-means, right? We were talking about we figure out which data point is closest to another. Now, what does that mean? Well, there are actually a whole number of ways of measuring that, but the typical way to do it is just Euclidean distance, right? Which is a fancy term for a simple idea. It's just literally the distance, right? The normal distance that you would measure if you were to print these data points out, essentially, right? So let's look at these two data points here, right? So if this was at like, you know, what does this look like? X equals 1 and Y equals 10, right? That's that data point there. And let's say this data point here is at X equals 2 and Y equals 8, okay? The distance between these two, this is the length of this line here, which you just calculate with Pythagoras' theorem, right? So this line here is 1, 2 minus 1. So it's 1 squared plus the y difference, that's 2, 10 minus 8, 2 squared, 2 squared, right? And then the square root of that. And so that is equal to 4 plus 1, so it's the square root of 5, right? And we're not going to try and figure out what that is. So that's the distance between these two data points, all right? And so what you do is, I'm just going to undo all this stuff, right, is you figure out, and of course there's just a simple way of doing this in R, the distance from every data point to every other data point. And this is where the hierarchical algorithm starts. And it says, well, what are the two data points closest together? And it says these two are. All right, so it says, right, I'm going to put this in a cluster. Boom, cluster done. Then it does the same thing where it now calculates what is the distance between all of the data points from all of the other data points. But this time we have a cluster. And now it has to measure the distance from the cluster to all of the data points. And how does it do that? Well, this is something called a linkage, because it turns out there are lots of different ways. Now, any normal person would look at this and go, oh, well, the distance must be from the middle of this data point here, the middle of this cluster to all of the other ones. Whoops, that wasn't supposed to be that. That was supposed to be that, right? So the middle to all of the other ones, that's the distance. And that is a linkage. That's called the centroid linkage. But there are lots of other ways we could do it. We could look at from the closest data point to another. We could measure it that way. We could measure from the furthest to the furthest, which would make more sense if I had already done some more clustering. And we can measure the distance from all data points in the cluster to all of the other data points in the cluster, and then take the average of those. That's called the average linkage. And another method, we don't literally measure the linkage, but in order to decide what to do next, well, let's keep going a few more steps, and we'll talk about that one in a second. So we so who is closest together next? So we cluster these two, right? And now we have another cluster. And then we go through and measure the distance from all the clusters to all the other data points. And then we say, well, I think the next closest one might be these two. So we cluster all of these together. And then we say, okay, the next closest ones together are these. And then finally, we cluster everything together. Okay, that was a terrible. Let's try that one more time. Right. Now, this may seem a very strange thing to do. After all, we've clustered everything together, which was that not like the complete opposite of what we were trying to do? Um, and the answer is we need to consider these distances and what was happening, the distances and the order at which we got them. So what do I mean by that, right? So when we clustered these first two together, they were very close. Right, so the first ones, the distance was close. The next ones, the distance was close. Now, when we clustered these third ones, the distance got a little bit further away between the cluster and this data point, right? But it wasn't that much further than before. These circles aren't much bigger than before. But if we imagine that there are actually two clusters here, well, when we cluster these two, we find that they are very far apart. Okay, so what that means is, on average, as we cluster data points within a cluster, they are very close together and they'll be clustered early in the process. While when we cluster data points that are far apart and in different clusters, they will be clustered late in the process and the distance will be very large. So if we could somehow plot the distance of the between any clusters versus the order, we could get a clear indication of how many clusters are in our data. Now, you, probably because you're sensible, are imagining a graph where we do something like this, where we go the number of clustering steps along the x-axis, right? And then on the y-axis, we have the distance, okay, the distance between our clusters, and what we would expect to see is, it going along and going, well, they're quite close together, they're getting a little bit further apart, right? And then, boom, huge jump, okay? And then pretty soon we're probably going to be done clustering, okay? And somewhere it was at this step here where we were clustering within a cluster, and then all of a sudden we were clustering the separate clusters. Well, that's not what we do, right? We produce something called a dendrogram. So we're going to do hierarchical clustering in the next video, and we are going to look at a dendrogram and learn to understand